Hello, this is question 11 in your pure paper 2 from November 2021 from Edexcel, and you have a sketch of this graph here, which is an absolute value graph, where k is a positive constant, and they ask you to sketch the graph with this equation, which is slightly different. We have to find the coordinates of the maximum point and the coordinates of any points where the graph cuts the coordinate axis. So first I will locate, because it's going to be helpful, these points here. So this is the original function. The original function cuts the x-axis when y is 0, which means 2x is 3k, which means x is 3/2 of k. So this point is 3/2 k. And the y-intercept here is going to be when x is 0, so minus 3k, absolute value 3k. So this point here is 3k. And now we are going to think, what are we doing with this? We have a minus at the front of this function, which means, remember, when I have a minus at the front of the function, when I have minus fx, I'm mirroring in the x-axis, because all my y's are going to be multiplied by minus. So all my positive are going to be negative and my negative are going to be positive. So this bit here without the k is this function mirror in the x-axis. Then if I have k here, k is the same that adding k. So this is the same as this, really, right? And every time I add k to a function, I'm moving it up by k. So my new function is going to be mirror and then move up by k. Yeah, so I'm going to do it in this page because I have more space. If I move that up by k, and this is 3k, I know this point is going to go like 1/3 of this space. Yeah, that's what I'm going to do. So if this is 3k, k is going to be somewhere here, roughly. So my point is going to be here, and then it just goes mirror. So it will do something like this. Yeah. So this is my new function. They ask me to find the coordinates of the cut with the axis and this maximum here. Okay, let me first do this one because it's the easiest. The mirror function, before moving it up, was cutting here in the minus 3k. If I move it up, it's going to cut in the minus 2k. So this point here is minus 2k. And then these 2 points, we are going to find them just making y equal to 0. We are just going to find the roots of our function. And our function is k minus the absolute value of 2x minus 3k. Remember, every time I have an absolute value function, it's like having two functions, two different functions. One is this one is this one. So I have like 2 branches, one with the plus here and one with a minus. So I'm going to solve 2 equations. One is going to be k minus 2x minus 3k equals 0. And the other one is going to be the same, but with a plus, k plus 2x minus 3k equals 0. If you solve the first one, you have k minus 3a is minus 2k is equal to minus 2x, so x is k. And if you solve the other, no, sorry, you have minus. So you have 4k divided by 2x. 2 is going to be 2k. And the other one is going to be k minus 3k is minus 2k equals minus 2x. X is 1. Just solving for x. Yeah. So these are the coordinates of my cuts with the axis here. So this is going to be k. This is going to be 2k. And I need the coordinates of the maximum point. Maximum point here, you see, we say is the minimum point of this one is 3/2 of k. When I mirror, this doesn't change. And when I move it up, it just moved up. So the x coordinate of my maximum is going to be the same that this minimum here. So the x coordinate is going to be 3/2 k. 3/2 k. So this point here is going to be 3/2 k. And my y has gone up k, so it's going to be k. Yeah, so the coordinates of my maximum is 3/2 k, k. And then they ask me, what else? Find, in terms of k, the set of values with this function. So my function, the one that I just represent, is over this straight line. This is a straight line. Y-intercept is minus k and gradient is 1. So it's a line that is something, I don't know exactly how it looks, but it will be something like this. Yeah, so a straight line, gradient, this is not in the middle, it should be in the middle, but minus k. And they are asking me when my function, the blue one, is above, so it's greater than the pink one. So they are asking me about this part here. Yeah, so what we are going to do is to find these points of intersection and then say that our answer is between this point and this point, because then it's above. To find the points of intersection, I'm going to do something very similar to this. I'm going to get my two functions and I'm going to use the plus and the minus for the absolute value. So I'm going to make my function with the minus at the front equal to my line, and the function with the plus at the front, with the plus at the front equal to my line. And I just solve it. So if I solve this one, I have that x is plus 3k 5/3 of k, so 5/3 k, that's the first one. And if I solve this one, I have 2x 3x x equal to k. So these are these 2 points. So this one is the smallest, the k, and this one is 5/3 of k, which means that our function is above the line when x is between k and 5/3 of k. Yeah, 5/3 of k is greater than k, so this is the right hand point and this is the left hand. But they asked me the answer in set notation, so please don't miss the mark for that. In set notation, I'm going to write, and I don't have the equal. Yes, that's why I don't write here any equal, it's just smaller. So in set notation, this is going to be the fancy bracket x, and then x must be greater than k, and at the same time, so intersection, again fancy brackets, x with x smaller than 5/3 k. So I'm just rewriting this in set notation. Then for C, so the last bit, they say, find in terms of k the coordinates of the minimum point of the graph with this equation. Minimum point. So this, the minimum point. So I have my function, and I do f of, so I'm doing f 1/2 x. Remember when I do f 1/2 x, I'm doing a horizontal stretch with a scale factor, the reverse. So scale factor is going to be 2, which means all my graph is moving, is spreading. Yeah, so this is going to be doing something like that. Yeah, so my x coordinate is going to be multiplied by 2, any x coordinate. So in this case, the maximum is going to be multiplied by 2. So my coordinate is going to be 3k. So the maximum for C, maximum is going to be 3k. And then the y coordinate, that it was k, is going to be, so this is my y coordinate really, it's going to be multiplied by -5, so it's going to be -5k, and I'm going to have a 3 at the front, so it's going to be 3 minus 5k. And I say k because the f of the maximum, so the y of the maximum is k. Yeah, we have it here, is k. So my y of the maximum is 3 minus 5k. And those are my coordinates of the maximum. Yeah, and that's all with this exam question.